these all started revolving around the sun. And that's why some of the planets like Jupiter, Saturn, Uranus, Neptune are still in a gaseous state, whereas the terrestrial planet, it means Mercury, Venus, Earth, Mars, they have cooled enough to translate themselves from gas to molten state and to the present solid state. What does this geoid shape indicate? Now, since the Earth is rotating on its own axis, there is a centrifugal force which is experienced at the equator of the Earth. There are two types of forces which are associated with rotatory bodies. How did the Earth came into existence? That would be our first question for the day, and for which we will try to have an answer in the due course. So the question is, how did the Earth evolve, or how did it came into existence? Today, if you have a look at the Earth, you will see that it is a rocky planet. It is the third planet in the solar system, and in fact, it is the largest of all the terrestrial planets. Now, the planets that are there in the solar system could be divided on the basis of their composition as rocky or terrestrial planets and Jovian planets. Jovian planets are those planets which are made out of gas, whereas terrestrial planets are those planets which are made out of rocks. So there are 4 such planets which are made out of rocks. They are Mercury, Venus, Earth and Mars. And if you have a look at all these 4 terrestrial planets or rocky planets, you will find that the Earth is the largest. So our planet is the largest. It means its volume is maximum. In fact, its density is also more than any other rocky planet in the solar system. So ये Earth existence में कैसे आया? How did the Earth evolve? You see that only thing that we can have, or the only understanding that we can draw with respect to the evolution of the Earth, is based on hypothesis. मतलब किसी के पास एक श्योरिटी भरा हुआ आंसर नहीं है. लोग बस इंटेलिजेंट assumptions करते हैं कि अर्थ हो सकता है इस तरीके से इवॉल्व हुआ होगा. And one such assumption is the assumption known as the nebular assumption. In fact, nebula, the term nebula means a cloud of dust and gas. Some astrophysicists or some astronomers, they believe, along with earth scientists and all, they believe that in the early phases of the universe, what happened was that all stars had a nebula in and around them. And we know that the sun is also a star. So sun also had a cloud of dust and gas around it. This cloud of dust and gas was slowly revolving around the sun. Now, you know, if gas cools, it will turn into liquid. And if liquid cools further, it will turn into solid. So it is believed that the planets, both the terrestrial planets as well as the gas giants, they all are created out of this slowly rotating primordial nebula, which has cooled in the due course. Or in other words, बहुत सालों पहले, and when I say बहुत सालों, it means billions of years ago, what happened was that the sun was surrounded by a cloud of dust and gas. Now that cloud was known as nebula. This nebula kept on rotating or revolving around the sun. With time, this nebula cooled, and as it cooled, the planets came into existence. Do you understand that? Because you can understand, if gas cools, then it would first turn into some liquid kind of thing, and if it cools further, if you cool liquid further, it will turn into solid Clear? And that is how you can understand the planets might have come into existence. That's one hypothesis which is known as the nebula hypothesis. There is another hypothesis which is known as the passing star hypothesis. So let me talk a few things about it as well. The passing star hypothesis. Let us have a look what happened under, or what is the argument under this hypothesis. It is believed that when the sun was very early in its existence, what happened was there was a big star, a star which was much larger in size than that of the sun, moved very close to the sun. Matlab, sun was very young. Suppose the sun is just born. Do you understand that? And a very powerful star which was much more bigger, had a lot of more gravitational attractional force than that of our sun, passed very close to the sun. And when it passed very close to the sun, it exerted an enormous gravitational pull on the surface of the sun. And we know that the sun is made out of gas. And if there is a gravitational attractional force over the surface of the sun, what happened was a part of the sun was separated from the sun, and that part which got separated from the sun due to the gravitational attractional force of that passing star started moving or started going behind that star. It means something like this. Suppose this is our primordial sun. In geography, the term primordial is used to indicate what was in existence before present. Do you understand that? It means millions of years or billions of years ago. For that, we are using the term primordial. So I told you there was a primordial earth as well. So suppose this is our primordial sun, or in other words, this is the child sun, something like this. The sun has just come into existence. What happened was a very big star, which was much larger in mass, in gravitational force than that of our sun, was moving in the universe. And there came in a point when it came very close to our sun. As a consequence of that, it exerted a gravitational attractional force on the surface of the sun. And as a consequence of that gravitational attractional force, dekho hua ye, that a portion of the sun was separated from the sun and it started moving behind that giant star which was going along its own path. So this is what might have happened. Imagine this star, the giant star, as it was going along, this separated portion of the sun also started moving behind it, because this portion was being attracted by this giant star. And this is our remedial sun, or you can understand the leftover part of the sun which was left once this small portion was removed from the surface of the sun. But this star, look here students, this star was moving at a very rapid pace. बहुत तेजी से जा रहा था ये star. And therefore this removed portion of the sun could not keep pace with it. And thus soon it found, it means this piece, it found itself out of the field of gravity of this star. Star इतनी जल्दी से निकल गया पास से that this removed portion, it started trailing behind it, but since it moved at a great pace, it could not keep pace with it and thus was left behind. It means that small removed portion out of the surface of the sun could not keep pace with the movement of that giant star which was passing by at an enormous velocity, and therefore it was left stranded somewhere. And the moment it came out of the gravitational attractional force of that big star, it came under the influence of the gravitational attractional force of our sun. Do you understand that? And it started revolving around the sun. And in due course, you know that sun is made out of gas. It is mostly a body of hydrogen and helium gas. We will study about the internal structure of the sun in our future classes, don't worry about it. But think of this. We know that this sun is mostly a ball of gas and fire. So this separated part must have also been made up of gas. So this gas started revolving around the sun. Why? Because it came out of the gravitational field of that moving star and fell into the gravitational field of the sun. It is believed that this removed portion of the sun, which started revolving around the sun, cooled in due course of time, and from it the planets have evolved. Do you understand that? So this further might have got separated into 8 portions, because Pluto is no longer a planet now. It has been declared as a dwarf planet by the International Astronomical Union. So these all started revolving around the sun, and that's why some of the planets like Jupiter, Saturn, Uranus, Neptune are still in a gaseous state, whereas the terrestrial planet, it means Mercury, Venus, Earth, Mars, they have cooled enough to translate themselves from gas to molten state and to the present solid state. Remember the process of differentiation, where I told you that the different layers of the Earth were created on the basis of differences in density? And I told you that happened when the Earth was in the molten state. In the molten state, it means that Earth was sometime in the geological past in a molten state. Do you understand that? Today, if you have a look at the Earth, you will find that at least the surface of the Earth is made out of hard rocks. Clear? So today the Earth is in a solid state, but maybe sometime back in geological past it was in molten state, and if you further go back, who knows, it might have been in a gaseous state. These are the two popular hypotheses. I'm not saying that this is how the Earth has evolved. In fact, nobody can claim that this and exactly in this manner the Earth has evolved. There are other hypotheses as well, but as far as general studies is concerned, and that too the preliminary examination, this would be enough for us to carry forward to understand the structure of the Earth and different aspects of the Earth, or to have some fundamental knowledge about the planet Earth. Do you understand that? Now, you see that be it the nebular hypothesis or be it the passing star hypothesis, whatever be the hypothesis, एक चीज तो sure है that the Earth was sometime back a ball of gas from where it converted into a ball of molten state, and today it is a ball of solid. Do you understand this? And therefore you see that there is this testification of the fact that the Earth was, in fact, it has emerged out of some sort of gaseous cloud or from the body of the sun. Many times you would see some books in geography writing that the Earth is actually the child of the sun and the sun is the parent of the Earth. Do you understand that? Now, the Earth, it is believed that it was formed 4.6 billion years ago, or you can write 4,600 million years ago. That is what is the assumption. In fact, many geologists now agree that the time of formation of the Earth was in and around 4.6 billion years ago, counted from present time. Do you understand that? So, एक चीज तो हमने समझ लिया. How did the Earth evolve? Earth has evolved either out of a gas or a cloud of gas and dust, or it has evolved out of the body of the sun. यही दो popular theories है with respect to the evolution of the Earth. And how old is the Earth? It is believed that the Earth is 4.6 billion years old. Now, what is the shape of Earth and what is actually the size of Earth? So we will now have a look at the second question, which is what is the shape of the Earth? Now, you might have studied this in several books that Earth is a sphere, but it is not an exact sphere. In fact, the shape of Earth is geoid. Remember the term geography? which was derived from two Greek words, geo and graphy. Geo was short form for geoid, and geoid means earth-like or earth-shaped. What does this geoid shape indicate? Now, since the earth is rotating on its own axis, there is a centrifugal force which is experienced at the equator of the earth. There are two types of forces which are associated with rotatory bodies, and they are the centrifugal force, the force which acts away from the center, and the centripetal force, the force that acts towards the center. Because the earth is rotating on its axis, so there is a centrifugal force which is experienced at the earth's equator. And because of this, the equator experiences an outward bulge, or the earth bulges at the equator. And if the earth bulges at the equator, such bulging is compensated by the flattening of the poles. In other words, the earth is slightly flattened at the poles and slightly bulging at the equator. Earth is not a perfect sphere. It means the radius of the earth, when you measure with respect to the poles and with respect to the equator, is different. The radius of the earth with respect to equator must be slightly greater than the radius of the earth with respect to the poles. Why? Because the earth is slightly bulging at the equator. And why is this bulge? The reason is the centrifugal force which is experienced in and around the equator because of the rotation of the earth on its own axis. But you see that you must not conceive like this, that the earth is too flat at the poles and a lot of bulge is there at the equator. In fact, it is slightly flattened at the poles and slightly bulging at the equator. The earth is therefore a sphere, but not a true sphere, because a true sphere would have the same diameter whether you measure it from east to west or from north to south. But in case of earth, if you see, the diameter changes at the equator and over the poles. Do you understand that? And why is this? This is because of the rotation of the earth and the associated centrifugal force. तो एक चीज और हमने समझ लिया, that the shape of the earth is not a perfect sphere, it is a geoid. And what is a geoid? A geoid is a sphere which is slightly flattened at the poles and slightly bulging at the equator. अगर आपको मेरी बात समझ नहीं आ रही है, so you can do that. You can take a tennis ball and you can push the ball from both the poles, or you can make two poles over the ball and you can push it down, or you can push it towards the center from both the sides. And if you do that, what would happen to the central locations of the ball? It would experience an outward bulging. Do you understand that? It means if you create that bulge, the flattening would occur automatically. In fact, if you rotate the tennis ball at very high speed, and if you have an ultra slow motion camera, you will see that slight bulge at the equatorial locations of that tennis ball and slight flattening at the polar locations of that tennis ball. Do you understand that? So the same principle of momentum and angular momentum is applicable in case of Earth as well. Do you understand that? So क्या समझ लिया अब तक ये समझ लिया that the earth has evolved out of a nebula or out of the body of the sun. Second, we have understood that the earth is at least, it can be more than that as well, but generally it is accepted now that the earth is at least 4.6 billion years old. And we have also understood that the shape of earth is not a true sphere, rather it is a geoid. But let me tell you an interesting fact. There is a slight variation in the sphericity of Earth with respect to a true sphere. It means, think of a true sphere, a geometrical sphere, and if you compare the Earth's sphericity with respect to that true sphere, you will see a slight, only minor percentage points variation. In fact, the Earth is a more sphere than a basketball. In fact, the Earth is a better sphere than a basketball. A basketball is more away from a true sphere. Earth is more closer to a true sphere. So, इससे क्या पता लगता है? That Earth is slightly flattened at the poles and slightly bulging at the equator. Clear? तो ये तो Earth के shape की बात हुई. What is the size of the Earth? Now, when we talk about the size of the Earth, we can talk either in absolute sense or in relative sense. Relative sense means relative size of Earth with respect to other celestial bodies or say other planets in the solar system. I already told you that if you check in terms of volume of all the 4 terrestrial planets, Earth is the largest. It means Earth is larger than Mars, Venus and Mercury. Though in the entire solar system, it is Jupiter, which is the largest planet. But of all the terrestrial planet, it means those planets which have a rocky surface over them, Earth is the largest in terms of volume. But also in terms of density, you will see that Earth is the most dense. What is density? Density is nothing but mass per unit volume. The average density of Earth is, suppose this is the Earth, the average density of Earth is 5.5 grams per centimeter cube. That is the average density of Earth. But you must keep this in mind that as we increase the depth from the surface of the Earth, there is a constant increase in the density. And this has happened because of the process of differentiation. And what is differentiation? Differentiation is the process in which the elements arrange themselves in different layers as per the density because the primordial Earth was in a molten state. ये तो हमने कल ही देख लिया था, right? Now, look here. It means that the topmost layer must be least dense and the innermost layer must be most dense. And I told you that the 3 density based layers are Sial, Sima and Neptune. Neptune being the internal most layer of the Earth. Average density of the top layer is around 2.8 gram per centimeter cube. That of the intermediate layer is that of 3.1 to 4 gram per centimeter cube. And that of the innermost is around 11 to 13 gram per centimeter cube. And if you add them all and divide them by 3, you will get the average density of the Earth. तो एक चीज ध्यान में रखो that the Earth is not only the largest of all the terrestrial planets, not the largest in the solar system, but of all the terrestrial planets, it's not only the largest, but it is also the densest. And its average density is 5.5 gram per centimeter cube. Let us have a look at what is the average radius of the Earth. The average radius of the Earth, it means the distance from the surface to the center of the Earth, that average radius is 6371 kilometer. And why am I calling it as the average radius? Because you know that since the Earth is slightly flattened at the poles and slightly bulging at the equator, the radius would be more at the equator. It would be slightly less at the poles. You can understand that, right? In fact, if that is the case, then the diameter must also differ. In fact, if you have a look at the diameter, you will see one thing. At the poles, the diameter is around 7,900 miles. Whereas, this is at the poles, the diameter. Whereas at the equator, you see that the diameter is around 7,926 miles. If you just convert it into kilometer, it would read as 12,715 kilometers approx, and this would turn into 12,756 kilometers approx. Do you understand that? So, at the equator, the diameter is slightly more. आप इसको divide कर लो 2 से, तो आ गया आपका radius. Do you understand that? So बहुत बिल्कुल फंडामेंटल्स पे बात हो रही है अर्थ की, और बहुत सारे क्वेश्चंस भी आते हैं इससे. डोंट थिंक दैट दिस इज अ वेरी सिंपल टॉपिक एंड वी कैन डू अ लॉट अबाउट इट एंड इट इज वेरी इजी. डोंट गेट complacent with any part of geography, right? It can create questions which can cause confusion if you do not prepare these topics very well.